Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everyone. Welcome to lecture 3, AP Chemistry. Today we will continue on chapter 1, Atomic Structure and Properties. Elemental composition of pure substances. Matter is defined as anything occupies space and has mass, and is all around us. Solids, liquids, and gases are the three states of matter commonly found on Earth. A fourth state of matter, plasma, occurs naturally in the interiors of stars. A plasma is a gaseous state of matter that contains appreciable numbers of electrically charged particles. Matters can be classified to pure substance and mixture. Pure substance, matter having an invariant chemical composition and distinct properties. Could be element, cannot be separated into simpler substance, or compound, substance composed of two or more elements in a fixed proportion. Mixture could be a homogeneous or heterogeneous mixture. What properties distinguish solids from liquids, liquids from gases, solid from gases? To answer, liquids can change their shape, they flow. Solids cannot. Gases can undergo large volume changes as pressure changes. Liquid do not. Gases flow and change volume. Solid do not. How does a heterogeneous mixture differ from homogeneous mixture? How are they similar? Well, homogeneous mixture is a mixture in which the composition is uniform throughout the mixture. A heterogeneous mixture is a mixture in which the composition is not uniform through the mixture. How does homogeneous mixture differ from pure substance? How are they similar? Well, a mixture can have a variety of composition. A pure substance has definite composition. So mixture has a variety of composition, while the pure substance has definite composition. Both have the same composition from point to point. How can element differ from a compound? How are they similar? A molecule of elements contains only one type of atoms, molecules of elements. Molecules of compounds contains two or more types of atoms. Molecular elements like oxygen, like nitrogen, like ozone molecule, while molecules of compounds like water, H2O, or carbon dioxide, well, they are similar in that both are comprised of two or more atoms chemically bonded together. Classify each of the following as an element, compound, or a mixture. Copper. Well, copper is an element. Water. Water is a compound. Air as a mixture of gases. Well, it's homogeneous mixture. Gasoline, again, have a mixture of homogeneous. Okay, it's a homogeneous mixture. Okay, it's a mixture of different hydrocarbons. Filtered tea, homogeneous mixture. Freshly squeezed orange juice, it has liquid and solids, so it is heterogeneous mixture. Aluminum oxide, a white powder that contains a 2 to 3 ratio of aluminum and oxygen atoms. It is a compound. Law of definite proportions. In chemistry, the law of definite proportions, sometimes called Prosted's law, the law of constant composition, states that a given chemical compound always contains its component elements in fixed ratio and does not depend on its source and method of preparation. Molecular and empirical formulas. Chemical formulas that indicate the actual number of atoms in a molecule are called molecular formula. Chemical formulas that gives only the relative number of atoms of each type in a molecule are called empirical formula. So the actual number of atoms provides chemical formula. A relative ratio or relative number of atoms of each type in a molecule called empirical formula. Well, the molecular formula for hydrogen peroxide, H2O2, 2 hydrogens, 2 oxygens, whereas its empirical formula, HO, the relative number, HO. The molecular formula of ethylene, C2H4, that's the molecular formula. The empirical formula would then be CH2. However, for many substances, the molecular formula and the empirical formula are identical, like the one in water, H2O. That the empirical formula will be equal to the molecular formula. Write the empirical formulas for glucose, substance also known as blood sugar or dextrose, molecular formula C6H12O. The subscripts of an empirical formula are the smallest whole number ratio. The smallest ratio are obtained by dividing each subscript by the largest common factor. Here the largest common factor is 6. You divide by 6 will be CH2O. This is the empirical formula. Nitrous oxide is a substance used as anesthetic and commonly called laughing gas. Molecular formula N2O. As you can see, the subscript in here already the lowest integral numbers. The empirical formula then will be the same as its molecular formula, N2O. Law of conservation of mass. According to this law, during any physical or chemical change, the total mass of the products remains equal to the total mass of reactant. Total mass of products will remain as the total mass of reactants. If heating 10 grams of calcium carbonate produces 4 grams of carbon dioxide and 5.6 grams calcium oxide, show that these observations are in agreement with the law of conservation of mass. Well, reactant is 10 grams, products 4 grams, 4.4 gram carbon dioxide and 5.6 gram calcium oxide, it's 10 grams. So here the mass of reactant is equal to the mass of products. The observation then are in agreement with the law of the conservation of mass. What is the percent composition of potassium in potassium dichromate. Atomic weight given for potassium 39 gram per mole, chromium 52 gram per mole, oxygen 16 gram per mole. Well, the molecular weight of potassium dichromate will be then 2 times 39, 2 times 52, 7 times 16. So the molecular weight, molar mass of potassium dichromate will be 294 grams per mole. The percent composition of potassium will be the weight of potassium is 2 times 39 divided by the molecular mass 294. The result will be 26.5%. So the answer is A. An unknown compound is found to contain 37.47% carbon, 12.61% hydrogen, and 49.92 oxygen by mass. What is the empirical formula for this compound? A, C2H6O, B, CH2O, C, C2H4O, D, CH4O. Well, what we have to do is write the relative mass given: carbon 37.47, hydrogen 12.61, oxygen 49.92. That's by mass. Divide by molar mass. So it will be divided by 12 for carbon, 1 for hydrogen, 16 for oxygen. We get the relative moles. So the relative mole will be 3.12, 16.61, 3.12, divide by 3.12, you get here 1, you get here 4, you get here 1, so it will be CH4O, and the correct answer will be D. What is the percent of carbon by mass in acetone? Acetone molecular formula C3H6O. So the ratio of moles will be 3:6:1. To get the relative mass, you have to multiply the number of moles times molar mass for each element. So here will be 12, 1, 16. So the relative mass will be 36, 6, and 16. The total mass, sum of these numbers will be 58. To get the percent of carbon, you divide the weight mass of carbon by the total mass. So will be 36 divided by 58. We need percent, so multiplied by 100. So the answer will be 62, which is the correct answer then. E. Suppose the mass of an unidentified substance is determined to be 53.3% carbon, 11.1% hydrogen, 35.6 oxygen. It is also discovered that the number of moles of this substance in a 100 gram of sample will be 1.1 mole. What is the empirical formula for this substance? What is the molecular formula of this substance? Well, the empirical formula, A, or the answer will be B or C. The relative mass given: carbon 53.3, hydrogen 11.1, oxygen 35.6. To get the relative mole ratio, we divide by molar mass, so it will be 53.3 divided by 12. Here hydrogen will be divided by 1, oxygen will be divided by 16. So here we will have 4.44, 11.1, 2.23. Divide by the common factor 2, this will be 2, 5, 1. This is the empirical formula, C2H5O. Let's check the molecular formula then. We have the 100 gram contains 1.1 mole. So what we have to do here is say the molar mass will be weight mass divided by number of moles. Mass is 100, number of moles 1.1. So we have the molar mass of 91. 91. And we have the molar mass from the empirical formula, C2H5O, total of 54. So the multiplier will be 91 divided by 42 will be 2. So we have to multiply the subscript by 2. So the molecular formula will be C4H10O2. And the answer will be number C. Suppose it is observed that 360 grams of carbon, 40 grams of hydrogen, 280 grams of nitrogen, and 320 grams of oxygen all react to form 1 kilogram of a new substance. What is the empirical formula of this substance? And again, we have 4 answers to select from. The relative mass ratio given 360 for carbon, 40 for hydrogen, 280 for nitrogen, 320 for oxygen. And then the mole ratio will be divided by molar mass of the elements, so 360 by 12, 40 by 1, 280 by 14, 320 by 16. We give you 30, 40, 20, 20. Common will be 10 divided by 10, so it will be 3, 4, 2, 2. And the answer will be C3H4N2O2. Your answer is D. C3H4N2O2. See you next lecture.